Okay, so this is your warm-up for today. I don't know how you did, but I'm going to fill in the answers for you, and you can check them against your own. Sound good? Chapter 6, Polygons and Quadrilaterals. This is the last section in this chapter. We're going to be covering properties of kites and trapezoids. So, I'm sure some of you know what kites and trapezoids are, so let's get cracking. Your learning objectives. I can use properties of kites and trapezoids to solve problems. Your language objectives. I can explain in writing the answer to the question, is it possible for the legs of a trapezoid to be parallel? Okay, here we go. Kite. What is a kite? Well, a kite is when you have two pairs of congruent consecutive sides. Okay, what do we know about the diagonals of kites? Well, the diagonals are perpendicular to one another. And there's exactly one pair of opposite angles that are congruent. Okay, so if you look over here at the kite, we can see two pairs of congruent consecutive sides. So this side's congruent to this side. The diagonals are perpendicular to each other, and we can see that right here. And there's exactly one pair of opposite angles that are congruent. So I have a congruent angle here, which is congruent to there. Okay, so here we have a kite, JKLM. We know that JK is congruent to JM. We know that KL is congruent to ML. So what we're going to try to prove is that angle K is congruent to angle M here. So our first statement is JKLM is a kite with JK congruent to JM, KL is congruent to ML. And you know that's just a given. Okay, then we have the reflexive property of congruent. Well, what's reflexive? One thing equaling to another. And if I'm trying to show triangles congruent, as you can see down here, right here, well, I'm probably going to look up here and say, okay, the only thing to show congruent here is side JL. So we're going to come back over here. So out of that, we get triangle JKL is congruent to JLM. Well, what is the reason? If you look up here, I have 1, 2, 3 sides congruent. Side, side, side. Last thing that we were trying to prove is angle K is congruent to M. And I know that because of CPCTC. So I can just say true angle M. Yeah, there you have it, guys. Okay, let's look at this kite EFGH. We know that FEJ equals 25 degrees. So FEJ, right here, 25. And FGJ equals 57. FGJ, right here, 57. So what does that mean about measure of GFJ? Well, I know because it's a kite, these angles here are perpendicular. So what I have is a right triangle. In a right triangle, the other angle here is 90 degrees minus this angle, because this one's 90, right? So here I'm going to get 90 minus 25. Oh, it's an ugly 5. 65 degrees. Okay? Over here, once again, I know that this is 57 here, FGJ, right angle, so this is 90 minus 57. Whoops, I did this backwards. GFJ. This one goes down here. JFE is the other one. So this one's 33 degrees. Get rid of this one here. So it's asking us, what is GHE? So GHE, what's the measure of this angle right here? Okay. Well, this angle here is going to be the same as the measure of this angle here. Not that one, this one right here. Okay. And I have a triangle right here. And I have one angle at 25, one at 57. So I have 25 plus 57 plus the measure of angle F equals 180. So if I just add 25 and 57, you get 82 plus the measure angle F plus 180. Sorry, this is so bad. I'm going to subtract 82 from each side, and I'm going to get the measure of angle F equals 98. And because angle H is the same as angle F, we're going to get 98 degrees. Sound good? Okay, here's one for you guys to do. So do this on your own. I am going to do it here, and you can check your work. Okay? So there should be your answers, 51, 110, and 62. So check your work on that, and we will keep going. Now we're going to talk about trapezoids. Trapezoids have exactly one pair of parallel bases, and non-parallel legs, or sides, are called legs. So exactly one pair of parallel sides, which are called bases. So you can see up here, these are the parallel sides. The non-parallel sides are called legs. In an isosceles trapezoid, the legs are congruent. Each pair of base angles are also congruent. And diagonals are also congruent. So I'm going to write that in here, and then you guys can catch up with me. So there you go. Isosceles trapezoids have congruent legs, congruent base angles, and congruent diagonals. So let's take a look at trapezoid WXYZ. In WXYZ, we're trying to find the measure of angle Y. So let's figure out what we know about this trapezoid here. Well, I have these two parallel sides, and this leg here acts as a transversal. Okay? So I have two parallel sides cut by a transversal. Well, if that's the case, then I know this angle here, same side interior angles. So what do I know about same side interior angles when I have two parallel lines? Well, they add up to 180. They're supplementary. So that means that the measure of angle X plus the measure of angle W equals 180. That's supposed to be an 8 there. Okay? So if angle W equals 117, I know that the measure of angle X is 117 equals 180. So if I subtract 117 from either side, I'm going to get the measure of angle X equals 180 minus 17 should bring us about, what, 63? Sounds good, 63. Now, because this is an isosceles trapezoid, I know it's isosceles because the two legs are congruent. That means the base angles are the same. So that would mean measure of angle x equals the measure of angle y, so y is going to also equal 63 degrees. Okay, so notice here, this angle would also be congruent to that angle. W and z would be congruent. Okay? Let's take a look at another problem. Here I have trapezoid QRST. I know that RT, the diagonal there, right here, is 24.1, and QP is 9.6. Notice also this is an isosceles trapezoid. Both the legs are congruent. So an isosceles trapezoid, the diagonals are congruent. And what else about the diagonals are congruent. So I know that RT is congruent to QS. Okay? So if QP equals 9.6, that means RP, this is also 9.6. So to find the length of PS, I just have to find the length of PT here, and it will be the same. Okay? So RT equals RP plus PT. Okay, so 24.1 equals RT, RT equals RP plus PT. Sorry, this is supposed to be a P up here. So 24.1 equals 9.6 plus PT. Okay, subtract 9.6 from each side, and we're going to get 14.5. So if PT equals 14.5, and PS also equals 14.5. So our answer up here is 14.5. Okay? So the next two problems are very similar. Example 4A and 4B. What I'd like you to do is to solve them on your own, and I will do them up here, and then we'll check our work at the end. Okay? Okay, you should have gotten 25.4. Okay, let's look at example 5. We're trying to find the missing value to prove that the trapezoid is isosceles. Well, in order to prove this is isosceles, we have to show that the two base angles are congruent. Okay, so let's find a value of y that would show them congruent. We can show them congruent by setting angle E congruent or equal to angle F. So I'm going to get 2y squared minus 25 equals y squared plus 24. It's a y, not an x. Okay, so let's subtract y squared from either side. I'm going to get y squared minus 25 equals 24. Now if I add 25 to either side, I'm going to get y squared equals 49. Take the square root, both sides, y equals 7. So up here, we're going to get a value of y equals 7. Okay? What I'd like you guys to do is to try to solve B. I think you can probably do it on your own. But if not, I'm going to be doing it up here silently. So, making a mess. So you should have ended up with 3.75. Okay? Okay, our last thing we're going to talk about is the triangle MIG, or the trapezoid MIG segment theorem. The trapezoid MIG segment theorem says that parallel to each base endpoints are the midpoints of the legs. So the mid segment runs parallel, you can see here, to the top base and the bottom base, and its endpoints bisect the legs. So it makes them midpoints. Okay? And the trapezoid mid-segment theorem says the mid-segment is 1/2, half the length of the sums of the bases. So if I add the top base with the bottom base, divided in 2, I'm going to get the length of the mid-segment. Sounds good? Let's try a problem. Okay, example 6. I know that ST is what I'm trying to find. Well, I know that the mid-segment is 1/2 the bottom base plus the top base. So I can just write an equation here. 31 equals 1/2 times 38 plus ST. Okay? So remember, we don't like working with fractions. The easiest way to get rid of a fraction is to multiply by the reciprocal. So let's multiply both of the sides of this equation by 2. I'm going to get 62 equals 38 plus ST. Okay, now if I subtract 38 from either side, I'm going to get 24 equals ST. Okay, you guys do B on your own. I'll do it up here so you have it when you finish. Okay? And you should have ended up with EH equals 8. Okay? That brings us our language objective. Is it possible for the legs of a trapezoid to be parallel? Explain why or why not. Okay, while you're working on that, I'm just going to tell you the homework right here. 6.6, pages 444 to 446, numbers 14 through 22, 27, 28, 32, 35, 43, 48. Also posted on Schoology for you guys. Okay? Your answer here should have been no, then it would be a parallelogram. Okay, you guys have a good one. I will see you again on Tuesday. Take care. Bye.